Okay, so just let me share my screen. Let me know when you can see it, please.
Yep, I can see it.
Awesome. Okay, so first of all, thank you all for your time. I hope to share some valuable information here. I don't expect you to have any previous knowledge on Azure functions. The idea here is to basically pass everything from the beginning until more advanced concepts. And as I said, the idea is to save time for you guys. Okay, so feel free to ask something in case it's not clear or if you want more information about what I'm talking. Okay, and VibeHub will help me with the questions because I'm not seeing the chat window at this moment. Okay, so my name is Thiago Cusodio. I'm a cloud solutions architect and also Microsoft MVP on the Azure category. Um, Azure Functions is pretty much my main service, let's put it this way, but I also know a few other things. I'm also the author of two books. They are published in Portuguese, so in case you speak Portuguese, it may be helpful for you. Otherwise, everything that is inside the book, you guys can find on the official documentation. It's just, some collection of receipts, let's put it this way. So one, it's about Azure. The other book is about cognitive services. Those are my social networks. You can find me on LinkedIn and on Twitter, both using the same alias, which is th.net. Okay, so I'll be very happy to get in touch with you guys and get your feedback after this session. Okay. So today I'll talk about those three main ideas: security, best practice, and performance. Some of the ideas that I'll share here may fall in more than one category, but in summary, this is what I'll bring to you. Okay. But first, let's just talk a little bit what serverless is. Okay, there are a bunch of definitions over there, but unfortunately, there's no official one. So, however, in every definition, you find some ideas. Okay, and one of these ideas is this abstraction of servers. So it means that we still need a server to run our code, but the difference is that we don't care. We don't care about the operational system. We don't care about the amount of memory, amount of CPU, disk space, and things like that. Okay, all of that will be responsibility of the cloud provider. The second idea is about event-driven scale. So it means that if your application receives more event, you have more instances of your application running, okay? And the opposite is also true. If you don't have any event, it means that there's no allocation for your application. And lastly is this idea of sub-second billing, what it means. So in serverless, you only pay if your application receives events and for the amount of CPU and memory to process that particular event. Okay, so as I just said, if the application doesn't receive any event, you won't pay at all. Okay. And as the main benefit, you save a lot in your cloud bill, basically. It's way easier to scale because you're basically delegating this to the cloud provider. And with that, you have more time to focus on what is important to your business. Okay. And to me, serverless is the natural evolution of cloud computing. Okay. And not only to me, actually, Microsoft also agrees with me. And now they also offer databases in this pricing model. So we have some of the APIs of Azure Cosmos DB. You can specify that you want the serverless mode. And as well, the SQL database, which is the SQL Server running on Azure, right? it also has the serverless mode. Okay, so you can work on databases as well. Besides database, we have three main services here. Azure Functions, which I'll talk about today. The Logic Apps, which allows you to create serverless workflows. So it's basically drag and drop of connectors. And these connectors, they implement authentication and some logic to connect to third-party services like Salesforce, Oracle, Twilio, Twitter, and many more. Nowadays they have, if I'm not wrong, over 300 connectors, and also some from the Microsoft like Office 365 and a few other Azure services as well. And also, there's another service, which is the Event Grid. I don't know if you guys are familiar or not. Unfortunately, it never received the attention it deserves. But what is the idea here? Event Grid is actually a repository for events. Okay, so those events, they can happen in your Azure subscription, or it can also happen in other cloud providers, for example. So basically, if your application works with domain events, you can publish those domain events to Event Grid, and then you allow other applications running on Azure to react to those events, basically. That's the idea, okay? And in fact, many of the integrations that we have in Azure, under the hood, they happen thanks to Event Grid, but it's not exposed, okay? Yeah, so this is basically the idea. Event Grid is super powerful, but as I said, it never received the attention it deserves. But anyway, let's talk about Azure Functions. What is the idea of Azure Functions? You basically write code that will get triggered whenever something happens, right? And then you implement your business logic and you output the response, basically. So we have this idea of bindings and triggers. So triggers is the event that will start the execution of your function, and bindings are they can be input bindings or output bindings. So for example, let's imagine that someone uploads a new content to your Azure storage account, right? They create a new blob over there. So you can have an Azure function that will get triggered to perform some transformation. Let's imagine that it's an image. You can shrink the image or transform to a different format or include some watermarks, something like that. And as the input binding, you can receive the array of bytes related to that blob, or you can receive the name and implement the logic to connect to the storage account and retrieve the content, things like that, right? And you can also work with output bindings. So what is this idea? So let's imagine, once again, you have the blob storage trigger. Your function will get triggered whenever someone uploads something to your storage account. You do some kind of processing, some kind of transformation in the blob, for example, and let's say that you want to output some metadata or some content to someone else. So you can use, for example, the Cosmos DB output binding, and the Azure Functions will be responsible to connect to your Cosmos DB and persist the data over there. So you pretty much save a lot of time dealing with, hey, how can I connect to this particular service using the latest version of the API and things like that. The Azure Functions take care of that for you, right? But most of the time, we actually work with HTTP triggers, so you can create APIs that will get triggered whenever someone perform a request against your API. But there's other possibilities here. Okay, you can get your function trigger whenever a new message appears in a queue in your service bus, for example, and then the function will dequeue the message, and you can process whatever it needs to do. Okay. At this moment, the official programming languages are those, so you can write your functions using C#, Node, F#, Java, PowerShell, Python, or TypeScript. Those are the official ones, okay? What do I mean by that? So if you code in one of those languages, you can find official SDKs provided by Microsoft, right? So it will basically interact with Azure APIs, and it abstracts some logic for you, okay? However, let's imagine that you don't work in none of those languages. You can still use Azure Functions and your favorite programming language. Last year, the Microsoft, they released this concept called custom handlers. So what is that? You basically use the Azure Function host as is, right? And it will call your code written in your favorite programming language. So let's imagine, for example, that you're a specialist in Go, and you already have a bunch of code written in Go, okay? So you can use this idea of custom handlers, and the function host will call your code running in Go, right? And then you can return the response to the function host, or you can also still use the Azure Functions output bindings to persist the output somewhere. Okay, so this is a very cool idea, and it basically lets you work with the non-official programming languages. Okay, there are many samples over there. If you guys search for one guy called Anthony Shu, he is a program manager in the Azure Functions team. He already created documentation and videos showing how to use Go, COBOL, and many other programming languages, the non-official ones. Okay. To host your Azure Functions, we basically use the consumption plan, which is the one that I mentioned before, where you only pay if your application received some event, right? And for the amount of time required to process that event. Or if you already have an app service plan, you can also deploy your Azure function over there. And this is ideal as well for long-running process. So if you have this demand for long-running process, the consumption plan is not ideal for you because you are basically paying per second, right? So using the app service plan, you already have some fixed cost associated to the app service plan, so you won't pay any extra dollar to host your functions over there. Okay, there are some other variations like the premium plan. You can also host your Azure Functions in the app service environment, which is a totally dedicated infrastructure for you. But those are variations of the app service plan. Okay, so the premium plan, basically, it gives you a better performance, and the app service environment gives you a totally isolated infrastructure. Okay. Cool. So let's talk about security now. As I mentioned, most of the time you guys will work with HTTP trigger. So this is also valid for regular APIs written in ASP.NET Core, right? But the idea is to not expose directly the endpoints, because if you need to, deploy a new version that will be a breaking change, for example, you won't break anything. So if you put an API gateway in front of the APIs, you can basically work with versioning of your APIs, and the callers, they can specify, hey, I want this version of the API, and there's no changes at all on their code. Besides that, You can also block unauthorized requests. For example, let's imagine that you only have callers in US and you detected in the API gateway that you are receiving requests from, I don't know, Australia or New Zealand. You can block their IP addresses, for example. Okay. Or let's say that a malicious user is trying to, implement some brute force against your APIs. So once you detect that, you can block that particular IP address, for example. You also have a centralized place for logging and audit, and as well a centralized place for authentication and authorization, and the communication between the clients and the API gateway, and the API gateway to your APIs. Everything is encrypted, so it's very safe. Okay. As I said, in the API gateway, on the official API gateway available on Azure is the API management. Okay. So you can work and create different versions for your APIs. And whenever you have a breaking change, you can create a new version, basically. And whenever you want to not support a particular version, you can, for example, route from version 1 to version 2 directly in the API gateway, and it will be transparent for your users. Okay? A very nice feature, very nice product, very nice integration. Sorry. Another interesting idea here, and I don't see many people using over there, and you should, is to assign a manager identity for your function. So in the past, we used to create system accounts, right, and associate to our applications on premises. And here is the same idea. You create manager identities and associate to your Azure functions. So whenever you want to grant permission to your function against a particular service, you do it granting permission to this identity. So it's very simple. You have your function, you come here to the identity, and you basically switch a toggle, basically from off to on, and you save. And it will automatically create a system account inside your Azure AD, and you use this account to grant permissions. Okay? And one of the integrations, and is also a good practice, is to store secrets outside your Azure Functions configuration. So the right place to store this kind of information is inside Azure Key Vault. So here we have a sample, not using Key Vault. We have the settings for your Azure function. Here, for example, we have a setting called super secret with the value 1234 at ASDF, right? So you actually will create the super secret inside Azure Key Vault, okay? And it will create for you a URL. So you get this URL, and instead of using the value in plain text, you use this @microsoft.keyvault, and inside parentheses you specify secret URI equals to the URL that the Key Vault will generate for you. And by doing that, basically Azure will handle the authentication against Azure AD, retrieve the token for you, pass the token to Azure Key Vault. Azure Key Vault will validate if the token was generated by your Azure AD, and in case the identity has permission to get and list the secrets, it will allow the function to retrieve the secret for you. So everything that I just described happens under the hood for you, and it's a good practice. So if someone with permission come here and they try to see the hidden value, they will only see this, but they won't be able to impersonate the identity associated to your Azure function. Okay. Cool. So let's talk now about some best practice. I would like to start talking about how big your functions should be, right? Many people ask, hey, how many functions can I have inside the function app, which is the aggregator of functions, and how big my function can be? And to answer that, I like to quote what it's in the Clean Code book. I don't know if you guys already read, but it's very valid. So the solid principles here, every letter represents a principle, right? And by following those principles, you have basically high quality code. Yeah, I love Uncle Bob's book as well. Someone just said here. So by following these principles, you have good quality code. Okay. And in one of the chapters of this book, he says about functions is not related to Azure functions, but function in a general way, right? But you can follow this because it's a good advice. So it says functions should do something or answer something, but not both, okay? And as well, one way to know that a function is doing more than one thing is if you can extract another function from it with a name that is not merely a restatement of its implementation. So by doing that, you know if your function is doing more than one thing or if it has multiple responsibilities, okay? Another good practice is to use dependency injection. So by doing that, your function will receive the dependencies, right, rather than instantiating the code. And by doing that, you allow the possibility to mock those dependencies and enable unit testing in an easy way, for example. And as well, you allow reusability of those components between multiple functions if you want, okay? Talking about performance now. This is important, especially if you use the consumption plan. So you need to detect whenever your application is not behaving as expected, sorry, because in the end it will mean that you are basically losing money. So the application insights is the recommended tool for you to monitor and measure the performance of your Azure functions. It's fully integrated with Azure functions and the official programming language that I said. And in here, you can also detect if a particular request failed, and you can dive into and basically detect on which line, why the failure happened, and things like that. You have an average of the response time. So you know, for example, if under heavy load, if your function is behaving as expected or not, an average of the request counts and things like that. Okay, so it's a really powerful tool. I really like Application Insights. I recommend this one. But if you guys don't want to use Application Insights, there are other tools over there. Sorry, you can use Dynatrace. You can implement your own basically telemetry data using something like Serilog, for example, and some other tool to visualize the data, like the Elastic Stack, for example, or even third-party tools like Datadog and things like that. Okay. You can also visualize what is happening pretty much near real time with your Azure function. So whenever, if you come here to live metrics, sorry, you have basically here a stream of requests that your Azure functions are receiving. And then in case something bad happened, you can click and dive into the exception as soon as it appears in your feed over here in the right corner, okay? Talking about durable functions, this is something very unique, very powerful. I love durable functions, and I strongly recommend its usage. So what is that? So durable functions, it was born in one of the internal Microsoft hackathons. they basically were observing multiple Azure functions, and they identify some patterns between different Azure functions. And from those patterns, they abstract and they created this framework. Okay, so with this framework, you can enable some patterns. One of them is called function chain. It's a very common pattern, and if we return here to what Uncle Bob said on this part, that you can extract some logic to another function, you end up with exactly something like this. So you have something on function 1, then you have function 2, then it calls function 3, then it calls function 4, right? But you need to save the state because something, some failure can happen between these stages, right? So the solution is to persist the output of this function into a queue. Then whenever a message appears in this queue, it will start the execution of the following function and so on until the end. Okay. So here we have a sample of the implementation. It's very simple to understand. We have here the function receiving a durable orchestration context. And in this context, we basically are calling the function 1, passing null as the input parameter. And we are storing, awaiting for the response, sorry. And once we have the response, we are assigning to a variable called x. Okay. Then once we have the response, we pass x as the input parameter for f2. And once we have the output, we are storing it in the variable y, and so on until the end. So as you can see, it's pretty easy to understand the workflow, and we are using code for that. Okay. The other pattern, and it's very common as well, is what they call fan-in, fan-out. So we have a function. This function fire requests against other function, but passing different parameters. You await for all these requests to complete. Then you are saving the output to a queue, for example, and then you trigger another function. So here is the code associated. We basically have a list of tasks. We have a loop, and inside this loop, we are basically calling f2, passing different input parameter, and we are adding this task to that list. Okay. Once we have all the tasks, we await all to complete, and once we have the output, here it's basically just performing a sum over the outputs of each tasks, and it's passing the sum to F3, for example. So it's pretty much this implemented as code. Okay, very powerful as well. So let me give you a real world experience using this pattern. Let's say, for example, that you want to buy a crypto, for example. So you can compare against multiple vendors like Coinbase or any other. You check, for example, the lowest fee, for example, and once you detect the lowest fee, you can actually perform the purchase against the cheapest one, for example. Okay. I mentioned that you can work with long-running functions. Okay. If you're using durable functions, they have a very nice way to do that. So it basically have an endpoint to start the execution. It will generate an ID for you, right? You start the processing, this long-running processing, and whenever you want, you have a separate endpoint where you specify the ID, and you can query if the work is completed or not. Very, very interesting pattern here and very useful as well. And it's already implemented for you in the framework. Other pattern here is to await external event. So for example, let's say that you want to escalate something and it requires human approval. Someone needs to review the purchase of a expensive equipment, for example, right? So you basically await for this approval, and the function will await for this external event, or you can also specify a timeout where it will abort the processing. And once it receives the event of approval or removal, for example, you can call whatever it needs to do after this approval or not. Okay. So those are the common patterns that are available using durable functions. And the last part of this presentation, I'd like to share with you some of the public cases from Microsoft using Azure Functions. Okay. The first one is this company, I believe they are based in Spain. And if I'm not wrong, they build auto parts. So they have these very large machines. Initially, telemetry data are only stored in these machines, and someone needs to go there and extract the information and analyze to figure out if something happened, basically. And now they built this solution, which basically auto extract this telemetry data from those machines. They stream this data to Azure using Azure IoT Hub, which is the entry point for this data. And they have a string analytics plugged into this Azure IoT, not into, on top, sorry, of this Azure IoT Hub. And it allows real-time queries. So let's say that something really bad is happening with the machine, they can fire an event and Azure IoT Hub will return this event to the machine that will stop the production, for example, or in case it's behaving as expected, they basically are storing this data into the storage account here in input blob, which will trigger the execution of a function that will perform some kind of transformation on top of this data, and it will output this, transform the data into another container or another storage account, which will also trigger the execution of other function, which will do some calculations, things like that, and store into Azure Table Services, right? And they also have here a dashboard that will allow visualization of what is happening in near real time. Very cool case, and it uses Azure Functions. The second case here is Fujifilm. They have this solution which sells baseball cards. So every game they have like thousands of pictures of the players, of the highlights and things like that. So they are uploading these high quality images to this solution, and they have the Azure Cognitive Search to perform search. Let's say that you want a picture of a particular player, for example, and they have a bunch of Azure functions here calling cognitive services to detect who is the player, and also some objects in the picture as well. So you can detect a particular brand of bat, for example, sponsors and things like that, right? So they are also using Azure Function for it. Very nice case. And lastly, I don't know if you guys are familiar about this one, but this initially started as a side project from another MVP based in Australia. His name is Troy Hunt. And this solution is called Have I Been Pwned or something like that. I don't know how to pronounce, sorry about it. But what they do, it's something like this. Whenever there is a data breach of some website, he's basically getting a copy of this data that got leaked, and he's hashing the passwords, and he basically have a very large database of leaked passwords. So the idea here is, for example, let's say that you have a bank or you work for a bank and you don't want your users to use, some weak password. So you can call the have an impound APIs, passing the password that the user is trying to assign, and you see how many times it got leaked. So if it's a very popular and simple password, chances are that it will got leaked many times. So in this example, he's hashing some password here like password 123 exclamation, and in the database he detected that this password appeared 615 times. So whenever you're calling the API, it will return the hash to points the number of times that password got leaked. Okay. And I like to show this particular case, and I also like to explain how functions are charged basically. So we use two metrics here. The first metric is called execution time. So you pay per gigabyte per second, sorry. So it's basically a metric that calculates the amount of memory, CPU, times the number of seconds that your function runs, basically. And the second metric is the total executions. So you pay based on those two metrics, right? However, the first 400,000 gigabyte seconds are free, and the first 1 million executions per month are free, okay? So you will only pay for what you exceed on those two metrics. So using the have I been pwned cost as an example, sorry, this is described in the blog post from Troy Hunt. Here, for example, on a particular month, he had over 500,000 executions. So if you remember, the first 1 million is free. So he basically paid nothing, right? Because the first 1 million is free. And he had here this 1,660,000,000 megabytes per second, which he performed some round to gigabytes per second, not megabytes per second. The first 400,000 is free, so it means that he basically paid for these numbers of 500,000 executions less than $1 per month. Okay. Using another month as example with some also real world numbers, he had 140 million executions, so it cost $27, and he had 468 billion whatever megabytes per second, which cost in the end $26. He had some bandwidth associated, so in the end of that month, it cost him $279, which is pretty cheap if you compare the number of executions he had on a month. Okay, so there is one trick here, guys. He managed to save a lot of money because he also used a CDN to deliver these hashed values. So most of the content is already in the CDN nodes, so very few requests actually hit the Azure function. So this is why it was so cheap for him to process that amount of requests. Okay, so this is it, what I had for today. I hope it was useful for you. In case something was not clear, I'm glad to provide more information. feel free to open your mic and ask something.
Thanks, Thiago. I don't see anything on the chat though. So yeah, anyone in the audience, if you have any questions for Thiago, feel free to unmute yourself and you can ask any questions that you might have, or if you would like to add anything to what Thiago presented.
Cool. By the way, sorry about my English. I'm improving it a little bit, and this is why I'm also here presenting. This is a way for me to train and practice. Hopefully, you guys understood something that I said.
I did. I didn't see any difficulties, Thiago. You're good.
Oh, good.
Hey, Thiago.
Yes.
If a function's been idle for a while and hasn't been used since you're paying by consumption, is there ever any like warm-up period when it first gets activated again, or is there something going on in the background to eliminate that?
Yeah. So you are right. There is a concept called cold start. So if you're using a consumption plan, you definitely will have cold starts because there's no pre-warmed instance of your application running. So once the Azure functions received the event, it will warn your function and it will pass the event and the bindings, the data, I mean, to your function, and it will get executed. But in case you need some near real-time processing, you definitely need some pre-warmed functions. So you should go with the premium plan that I described in the hosting model slide, which basically will allow pre-warmed instances of your application. But there is a cost associated. Okay.
Okay, thank you. Appreciate it.
You're welcome. So the team is working really hard to decrease these cold starts, but it's something that it's common, and all the cloud providers, they face the same problem, because otherwise, basically they are absorbing the cost themselves, right? So all other cloud providers, they have this idea of pre-warmed instances to deliver a better response time.
And some of these limitations might also differ based on which trigger type you are using. I've seen issues specifically with blob trigger.
Yeah, so what enables the blob trigger is the event grid. So there is some delay because what happens is the function host will consume the event from event grid, and it will start the execution of your function. So if you have something that reacts directly from the event grid, it will process faster than the blob trigger, for example, right? Because you are basically eliminating this job that the function host will do for you. So it will go directly from the event grids to your function. But you also have some delay between the moment that the blob is created in your storage account and the moment it starts processing whatever it needs to process. Any chance slides can be available besides the video record? Sure, I'll share with
Send it to me. I can post it on the YouTube channel under the comment section so that everyone can download it from there.
Cool. One last thing that I would like to say: every month, the functions team, they host a live event on their official YouTube channel. Let me share the link with you guys. So you can find the previous recordings over there. and you guys can stay up to date to whatever they are working. I just shared the link here in the chat window. In the past meeting, if I'm not wrong, they were talking about some limitations with the key vault reference, which is what I described, what I explained to you, that connection between the Azure functions and the key vault. They were talking about that, and some other things that I can't remember from the top of my mind, but the team is very open, very friendly. If you guys have feedbacks or you want to stay up to date to what's happening under Azure Functions, the lives they host, it's the best place.
I
Besides,
think the YouTube channel is a great resource.
yeah.
Sounds good. If you don't have anything, I would, on behalf of the user group, I would like to thank Thiago once again for taking time out and presenting in the user group today. I would also like to thank Spreetail for sponsoring the meeting today. I'll go ahead and stop the recording now. Thanks, everyone.
Oh, just one last slide, sorry.
Go ahead, Thiago.
I'm so sorry, forgot to share this. So I put here some links, the official docs, in case you guys need to learn more about input bindings, output bindings, durable functions, whatever, everything you guys can find over there. There is a shortcut for the YouTube channel, in case you need. It's bit.ly/Azure Functions YouTube. If I'm not wrong, I created this one. And as well, my social media contacts, the Twitter and LinkedIn at th.net. And if you guys want to learn more about those cases that I explained, you can find here microsoft.github.io/tech case studies. You can find more cases, not only those that I put in here. And it's very interesting because you can filter by a particular Azure service. So for example, you want to learn, hey, who is using the computer vision, for example, you find over there, right? You just check the service and it will present to you the case. And that's it. Thanks so much for having me today. I hope you guys enjoy. Sorry about my English, and that's it.
You don't have to be sorry, Thiago. Thanks once again.